Hello students, my name is Palak Jain and I am here to teach you a important concept of C programming language, that is recursion. So if you go through previous year GATE examination papers, you saw or you find every year they ask question related to recursion. So that's why this topic becomes more important for us to know. So today what we will see is what is recursion, and then I'll take one basic example to make it more clear. Okay, so let's get started with what is recursion. So, if we talk about a word recursion in English language, it means repetition. If I'll talk about in terms of programming language, recursion means a function which is calling itself again and again. So then this process is called as recursion, and function which is using this process is called as recursive function. Okay, so what you have to do is, what you have to understand is the meaning of recursion. Recursion means when a function is calling itself again and again, then this procedure is known as recursion. Now I'll take one example to make you guys more understandable about this topic. So I'm just taking a small example or very known example of recursion, that is factorial. I think you all know what is factorial. So before seeing this example or before seeing this program of recursion, we will understand what is recursion and how to solve factorial by using recursion. Then we will see that program. Okay. I think you know what is factorial. What is factorial? If I will talk about 4 factorial. What is 4 factorial? 4 into 3 into 2 into 1. You all know. If I will talk about what is 3 factorial, 3 factorial is 3 into 2 into 1. So what is happening? If I talk about what is factorial, so how I am computing it, 4 factorial means 4 into 3 into 2 into 1. Similarly, 3 factorial means 3 into 2 into 1. So what I am doing here is, I am starting this thing by the same number 4, and I am decreasing every time it by 1, and where I have reached it by up to 1. So what I am doing is, I am starting with the same number 3 and I am decreasing the number by 1, and where I am ending it on 1. So every time when I am calculating factorial of a number, I am starting the procedure by same number and I am ending that thing on 1. So if I am talking about 6 factorial, let's just take larger number. So what is 6 factorial? 6 into 5 into 4 into 3 into 2 into 1. Same thing, I have started with the same number itself 6, and I am decrementing it by 1 up to 1. Okay, so every time when I'll talk about factorial, I am starting the thing with same number and I am ending it on 1. Okay, so from here we understood one thing. So whenever we have to find a factorial of a number, we have to start the thing which the procedure with the same number and we have to end it on the 1. Okay, why I am talking about this? Because now we have to use, or we have to make a recursion function. Okay, so for recursion we need two things. For making recursion function, we need two things. First is base condition. Okay, and second is necessary condition. Necessary condition is the condition which is used for computing recursion, for computing our problem. Okay, and base condition is we have to stop on something. Okay, why we have to stop? Just let's see here. If I will talk about n factorial. Okay, so how I will compute n into n minus 1 into n minus 2 up to so on. So I have to stop it on something. Otherwise it will goes up to the infinity. Okay, so that's why I need one base condition on which this thing will end. So what is the base condition in factorial? 1. So we have to stop. We know whenever we will reach to the 1, we have to stop it. Okay, so every time we are doing this same thing. So whenever we reach 1, we are stopping it. Okay, so this is the base condition. And necessary condition is from which we can compute our function. Okay, so that's why we need two things, base condition and necessary condition. If we will get these two things, then our problem will be solved. Okay, so how we can make it as a recursion function? Can I write 4 factorial as 4 into 3 factorial? Is it true? Yes. How is it true? How is it true? We can say, because we can write 3 into 2 into 1 as 3 factorial. Here, see this. I am writing 3 factorial as 3 into 2 into 1. So can I replace 3 into 2 into 1 as 3 factorial? So what will be left? 4 factorial equal to 4 into 3 factorial. Right? Again, 3 factorial. What will be the 3 factorial? 3 factorial will be same. 3 into 2 factorial. Right? Because what is 2 factorial? 2 into 1. So I can replace 2 into 1 as 2 factorial. Right? Similarly, then what will be the next? 2 into 1 factorial. Then next 1 into, we all know 1 factorial is 1. Okay, so this is the procedure. What we are doing? We are just writing a number 4 into 3 factorial. Then again we are calling the factorial 1, and what we are doing? We are using 3 into 2 factorial. Then again we are calling recursion function. We are calling same function recursion factorial. Then again what we are doing? 2 into 1 factorial. Okay, then what is 1 factorial? We know 1. Then we will compute 2 into 1. This whole will become 2. So instead of 2 factorial, what we can write is 2. So replace 2 factorial by 2. 3 into 2 will make 6. So 3 factorial will become 6. 6 into 4, 24. So factorial 4 will become 24. So this is the procedure of recursion. So what we will do? We will first make a tree from top to bottom, and at the base condition we have to put that value, and then we will compute that value from bottom to top, and at last we will get our desired result. So this is the basic thing of recursion. Okay, so now if we will move towards this problem, this function or this example, so similarly we will make one program for this. So what I have took here is, I have make one function which is named as factorial. I took one argument in it as a integer type. Okay, because we are using factorial for integer numbers only. Okay, so see, this is the base condition here. What is base condition? When my n will become 1, we will stop, or we will return 1 here. Okay, otherwise what we will do is, similarly what we will do is previously is n into factorial of n minus 1. Okay, so let's get started. If I am taking the value of n equal to 4, so what will happen? 4 will become, or 4 will go here. So what will the value of, what was the argument here? 4. So what will happen? 4 will be compared by this. 4 is equal to 1? No. So this if statement will not work. What will happen? It will goes to else statement. So what is the value of n? N is 4 into factorial of n minus 1. N minus 1 means 3. Right? So what will happen? Again, see, same function, factorial with argument n. So it will become same function, factorial with argument n. Now the value of n is 3. This time value is changed. What will happen? Now this time value will become 3. See, 3 is equal to 1? No. Again this condition will not work. we will have to go to the else condition. What it will say? Return karo n into factorial of n minus 1. So what will happen? What is the value of n? 3. So 3 into factorial of 3 minus 1, that is 2. Again, see, this is the same function. So the function is calling itself again and again, factorial function. Now the values change. What is the value now? It will become 2. Compare it. 2 is equal to 1? No. Then it will go to the else condition. What it will write? N into factorial of n minus 1. So what is the factorial of n minus 1? Factorial of 2 minus 1, that is 1. Now again it will call same function factorial 1. Now the value of n is, this time it will become 1. See, now it will compare. 1 is equal to 1. This time this base condition will become true. So what it is saying? Return 1. So instead of factorial 1, now what I have to write is we have to return 1. So instead of again calling it, because I am reaching on the base condition, so I have to write 1 here. What will happen? 2 into 1, it will become 2. So instead of factorial 2, it will become 2. Again 3 into 2 means 6. Factorial 3 will become return 6 here. And 6 into 4, it will become 24. So in this way, we calculate the value of 4 factorial. So you also see in the recursion, function is calling here it again and again. So basically we use recursion to break bigger problems into smaller ones, because we can compute smaller problems easily as compared to bigger ones. That's why what we will do in recursion, we will break bigger problems into smaller ones so that we can find our solution easily. I hope you guys understand what is the basic fundamentals behind recursion, or what is recursion. Thank you.